For number 4, we're going to write an equation of a line containing the point -1, 2 and parallel to the line 3x plus y equals 5. Write the equation in standard form, which is ax plus by equals c. A, b, and c are real numbers. A must be a whole number. Remember, whole numbers 0, 1, 2, 3, 4, 5, 6, etc. Okay, so what do we know? We've got a point, x1, y1. Do we have a slope? We have the words parallel to this line. And so what do we know about parallel? Parallel lines have the same slope. So if I figure out what the slope of this line is, then I can find the slope of my line. So if 3x plus y equals 5, how am I going to find the slope? If I get this equation in the slope-intercept form, then I can easily identify. So let's opposite the 3x term from both sides. Then that'll be a negative 3x plus 5 on the right side. And that's in the slope-intercept form, y equals mx plus b. So the slope here is negative 3. So the slope of my line is negative 3, because it's the same. So I've got a slope and I've got a point. Well, let me just go ahead with point slope. So I'm going to use this form of an equation and fill in the point and fill in the slope. So y minus 2 equals negative 3 parenthesis x minus negative 1. So in order to simplify this, I'm going to have to go ahead and change that minus and negative to plus, because the opposite of subtraction is addition. Then I can distribute that negative 3 on the right side. So negative 3 times x is negative 3x, and negative 3 times 1, that's an identity, leaves me a negative 3. So I just need to get the number terms on the same side, so I'm going to add 2 to both sides of the equation. Then y equals negative 3x minus 1 altogether. But now I need to get this into the standard form, right? So I need my x term to be on the left side. So I'm going to opposite that. So plus 3x to both sides of the equation. Then 3x plus y equals negative 1. That's all that's left over there. And since the first number is a whole number, perfect. This is the standard form of this equation. For 5, write a function that describes a line containing this point, 3, 4, and perpendicular to this line. Write the equation in standard form. So we're going to need it in that standard form again, where a is a whole number. What are we given? We're given a point and the fact that it's perpendicular to this line. Well, parallel lines have the same slope. Perpendicular lines have opposite reciprocals. So m1 equals the slope, then the perpendicular will equal the opposite reciprocal. So different signs, flip the numerator and denominator. Okay, so let's see what the slope of this line is then. 2x plus 4y equals 5. Well, I have to get it in the slope-intercept form, so that means I need to solve for y. So let me opposite 2x from both sides. Then 4y equals negative 2x plus 5. And then divide 4 from both sides. And really, I don't care about the y-intercept. I only care about the slope, right? So if I simplify that slope, that's going to be negative 1/2 if you divide by 2 from both the numerator and denominator. So the slope of this first line is negative 1/2. So the slope of my line is going to be positive. Flip the numerator and denominator, 2 over 1, so just 2. All right, so I have a slope and I have a point. Let's go ahead and build the equation then with the point slope. So our point y is 4, our slope is 2, and x is 3. So then I just need to go ahead and distribute that 2 on the right side. So 2x and minus 6. I want my number terms to be on the right side, so I'm going to add 4 to both sides of the equation. And then y equals 2x minus 2 altogether. And then I need my x term to be on the other side, so I'm going to subtract 2x from both sides of the equation. So negative 2x plus y equals negative 2. And that's a problem because this is not a whole number for the a part of this. So I need to get this to be a whole number. So I just need to get rid of the negative sign, right? Then that's going to be a positive 2x, a negative y, and on the right side, a positive 2. That will complete the standard form there so that a is a whole number. And number 6, we have a word problem here. The value of a building bought in the year 2000 continues to increase as time passes. So the value increases. 7 years after the building is bought, it's worth $210,000. 12 years after it was bought, it's worth $270,000. Wow. So in part A, assuming the relationship between the value of the building and years after it is bought is linear, write an equation describing this relationship. Okay. Well, they're asking me to find a relationship between the years after it was bought and the value of the building. And the value depends on the number of years, right? The years doesn't depend on value. That would be weird. So we can come up with some ordered pairs based on that information. We know that it was bought in the year 2000, so years after it is bought will be years after 2000. We know it's increasing, so the slope of a line like this is going to be positive. That's what that means. So 7 years after the building was bought, it had a value of $210,000. 12 years after it was bought, so that's another ordered pair there, it was worth $270,000. So that gets us 2 ordered pairs, which is our first pair and our second pair. Then we need to build an equation of a line for these 2 ordered pairs. So the first thing we need, slope. You can't go anywhere without a slope. So I'm going to take the difference of the y, 270,000 minus 210,000, over the difference of the x, 12 minus 7. So that difference on the numerator is 60,000 over 5 years. So when I divide that, that's going to be 12,000. So the slope is 12,000, and that means every year the value of the building increases by $12,000. But I still need an equation. Okay. So I'm going to take one of these points, smaller numbers, and I'm going to build an equation here. So y minus the y coordinate equals slope, 12,000, times x minus the x coordinate. So I need to distribute on the right side 12,000 times x is 12,000x. 12,000 times negative 7 is negative 84,000. And then I need to get y by itself. So I'm going to add 210,000 to both sides of the equation. Then y equals 12,000x plus 126,000. And then if I just change that to function notation, f of x equals 12,000x plus 126,000. And that y-intercept, that's when x is 0. So that's in the year 2000, the building was originally purchased for $126,000. And every year it goes up by $12,000 in value, which is pretty sweet. So we've got our function here. Then we want to use this function equation to estimate the value of the building this year. So this year is 2020. And if it was purchased in 2000, that means it's been 20 years since it was bought. So we're going to evaluate the function after 20 years. So every year is $12,000 times 20 years, plus the original value of $126,000. So that's going to be 24 with 4 zeros. Wow. And if we add those together, then that's $366,000. So $366,000 is the value of the building this year. And that's amazing.